So my name is Clinton Stone, and I'm a technology specialist with SIMTEQ Engineering in Pretoria, South Africa. So the VTX-200 is a desktop educational wind tunnel designed for engineering students and lecturers to be able to give students the ability to perform real aerodynamic experiments right in the classroom or in the lab environment. The idea was to come up with a wind tunnel that could allow students to bridge the gap between both the simulation world and the physical test world, and actually to engage with flow in a real educational but also a way that builds engineering intuition. It's designed to be compact, affordable and easy to use for both undergraduate students and master's level research projects. So the VTX-200 wind tunnel actually allows students to see how the air behaves in real time and not just calculate it theoretically or with computer simulation. They can measure things like lift and drag directly on 3D printed models that the students design and print for themselves, and they can also monitor the pressure at different locations in the wind tunnel to understand the flow while visualizing it all in real time. So most educational wind tunnels at university labs around the world are either too simple or too complex or too expensive. You either get a simple fan in a box, or you get a full-scale research wind tunnel that is so expensive to run and so complicated to use that only designated staff members are allowed to use it. So the design of the VTX-200 is meant to be plug and play from the get-go. The sensors, the fans, the LED lighting are all electronically integrated into a touchscreen interface that's very simple and intuitive to use. So students can print a 3D model, mount it in the wind tunnel, hit start, and immediately begin visualizing the results of the flow. No calibration headaches are involved and no complex setup is required. It is also Wi-Fi enabled, and it includes a web app that allows you to access the real-time data on your phone or a tablet or a laptop. It allows students to view the data being recorded in real time, and it allows them to then export the raw data from the experiment to external software like MATLAB or Excel or Google Sheets for advanced post-processing. So the VTX-200 supports 6 load cells, 2 mounted on the rear wall to measure lift and drag, and 4 mounted in the floor, as well for front and rear force measurements, for example, on vehicles or floor-mounted models like aircraft. It also supports flow visualization, which is achieved with fog streamlines, and enhanced customizable LED lighting helps to make the visualization of the streamlines that much more clear. Students can run experiments on aerofoils, airplanes, car bodies, buildings, wings, drones, and any shape actually that you can 3D print. It's really a full aerodynamic lab on a desktop. So one of the challenges we've discovered in modern engineering education is that students graduate with lots of knowledge about the theory, but very little engineering intuition. And the goal of the VTX-200 is to really enable a student to gain physical engineering intuition in the whole field of fluid dynamics and aerodynamics. The ability to link what they've learned in the classroom, in theory, with what actually happens in the real world. So for example, a student can actually get to see and measure what happens as the angle of attack of a wing changes, and not just predict the stall angle based on theoretical answers or mathematical calculations, but actually correlate that visually by both seeing how separation occurs over the wing and how both the lift decreases and the drag increases as a wing stalls. So SIMTEQ has been empowering engineers with simulation tools for nearly 3 decades. And the VTX-200 is our way of giving the next generation of engineers the missing piece, which really is hands-on experience. It's robust, it's affordable, it's locally supported, and it's designed specifically for the realities of modern engineering education. And so simply is a must-have for every engineering institution that is serious about educating the next generation of aeronautical and mechanical engineers.